I hope everyone is able to understand the schematic design part. We will now design the schematic of USB and its circuit. Before that, let's look at the datasheet of the CH340 IC. CH340 IC is basically a USB bus converter chip. It is an IC to program the microcontroller, we will use the USB. So the USB will be connected from our system or that is a laptop or the computer to the board which we are creating. So the board should have some USB to UART converter. So it is a USB to serial UART interface. So these are the features of the CH340 IC. It is a 16-pin IC. So these are the packages. We will use the CH340 IC. Now let's draw the schematic of this IC. You need to search for CH340 GIC in the schematic window. Search for CH340G USB serial converter. Okay, what else we need? We need there is a basic circuit of this CS340 IC which is important. This IC also works on 5 volt. Let's draw the basic circuit. We need one capacitor, 10 nanofarad. This is 10 nanofarad. This is pulled to ground. We will take this ground from our circuit. Also, we need zero point 0.1 microfarad at the VCC pin. We can just copy the zero point 0.1 microfarad capacitor from our circuit. Okay. Now we should have one USB mini. We will use the USB mini connector. Okay. So if you notice, we have this V bus, which is the positive rail, which will come from the laptop or the system. Data plus, data minus, ID we will not use. That is no connection, and this shield is grounded. So to reduce the frequency component, we will use this capacitors. So the data plus and data minus will be connected to this UD plus and UD minus of the CS340 GIC. So we will use a label. So I will connect the data plus at this UD plus. You can just copy and connect this. Okay. So whatever the data plus and data minus coming from the USB will go in this CH340, and via TX and RX, that is UART interface, it will be connected to the microcontroller. Okay, so we will connect this TX and RX to this microcontroller. For that, I need 1K registers. Okay, I can just place it down. Okay, I will use the same label, but you should notice that this USB RX. So this is the TX part, so it will be connected here. It is same like I am transmitting something and you are receiving it. The same way to RX also. Okay, now we are done with this part, but we need for this IC to work, we need an external crystal oscillator. We will use a 12 megahertz crystal. To search for crystal, I need two capacitors. So I need 22 picofarad. So I can just copy this. Now we are left with some of the pins. In this, only one is important, that is BTR. We need a zero point 0.1 microfarad capacitors so that this IC should work. And this DTR pin is connected to the RST pin. Okay, all of the other pins of this CS340 GIC will be not connected, so we will just use this no connection. Okay, so if you notice that this V bus will have the positive rail, so what will happen here? The 5 volt will also flow from the laptop or your system to this board. Okay, so what we will do is we will use a diode, so that 5 volts will come in from the USB, but it should not, like for example, if this barrel jack is connected with the power source, so the board is powered and we will get 5 volt at this pin also. So what will happen here is the 5 volt will flow in the system or the laptop. So what we will do is we will just connect one diode so that this will not happen. I can just copy this diode. So what will happen here is, so in this case, the 5 volt from the USB will go in the circuit, and the 5 volt from this barrel jack will not go in the USB. Okay, so we are done with the USB circuitry. I can just name it. One more thing is that if you used If you change the value, like I think we should use 1 microfarad, and also we can have one 4.7 microfarad to reduce low frequency component. Sorry, we can use one capacitor polarized 4.7 microfarad. I can just name this USB circuit. Okay, just have a look at this schematic and verify the schematic whether all of the connection is done properly, and we will move to the next part in the next session. Thank you.